Good morning. Today we are solving linear and literal equations. So a linear equation is an equation with a single variable. So we find this by isolating our variables. So here on example 1, the first thing I'm going to do is distribute this on both sides. And that would, oops, I've already messed up. I apologize. That should be negative 25x plus 2,500. And then on the right, we're going to distribute that 16. Okay. And then just good old basic algebra 1, we're going to get all of our x's on one side, all of our constants on one side, and we get that 2,660 is equal to 41x, divide by 41. And we're just going to leave this as an improper fraction. 41 is a prime number, so we can't reduce this any further. And that is our value of x. Now, on example 2, and for the rest of these problems here on out, what we're going to want to do is clear fractions. So, in example 2, I've got denominators 9, 3, and 8. And in order to clear those fractions, I need to find the least common multiple between 9, 3, and 8. And that is 72. So I'm going to multiply my entire equation, every piece of it, by 72. So I'm going to get 72x over 9 plus 72 over 3 is equal to 792 over 8x. And now I'm going to simplify. So 72 divided by 9 is 8. 72 divided by 3 is 24. And 792 divided by 8 is 99. So that's a much prettier equation to solve. We cleared our fractions, and now I'm going to get x by itself. So 24 is equal to 91x, divide, and we're going to, again, just leave this as a fraction. So x is 24 divided by 91. Okay. Number 3, I am going to go ahead and distribute my fractions. So 4x over 3 minus 4 over 3 is equal to 1/2 x plus 3 over 2. And again, I want to clear my fractions, so I need to look for the least common multiple between my denominators. Here my denominators are 2 and 3, so that least common multiple is 6. So I'm going to multiply my entire equation, every single piece of it, times 6. So I'm going to get 24x over 3 minus 24 over 3, and I apologize, that should have been 8 over 3, so that is actually going to be 48, is equal to 6 over 2x plus 18 over 2 minus 24. So now I'm going to simplify, so that's going to give me 8x minus 16 is equal to 3x plus 9 minus 24. And again, get all my x's on one side, get all my constants on one side. So 5x is equal to 1. So x is 1/5. Now going on to our last example for literal equations, I'm going to start by going ahead and combining some of my like terms just to make things a little bit simple. I'm going to move that 7x to the other side, and that's going to give me 10x. Now I'm going to distribute my 8/5, so that's going to give me negative 40 over 20x minus 16 over 5. Now this negative 40 over 20 actually reduces to a whole number, and that's going to be negative 2x. So I'm going to move that 2x to the right side, and we get negative 16 over 5 is equal to 12x. Now I'm ready to clear my fractions. So my only denominator is 5, so I'm going to multiply my entire equation by 5. So I'm going to get negative 80 over 5 is equal to 60x. Now negative 80 over 5 reduces to negative 16. And I'm going to divide. So x is negative 16 over 60, which reduces to negative 4 over 15. And we're just going to leave it as a fraction. onto the back side, on literal equations, so this is an equation that has more than one variable. So when you're given a literal equation, you're going to be told which variable you're solving for. And that means you're going to get that variable by itself, just using algebra to isolate it. So starting with this first example 5, if I'm going to get y by itself, first I'm going to subtract that 2x. So 3y is equal to negative 2x plus 9. And then my last step is going to be to divide everything by 3. So y is equal to negative 2/3 x plus 3. Now hopefully this looks a little familiar to you because you have definitely taken an equation written in standard form and turned it into slope-intercept form. And that's what we just did here on example 5. All right. So there are other cases where we have more than 2 variables even, and on this example 3 we want to solve for r, meaning we want to get r by itself. So r is this term here in the middle, and I'm going to highlight it, and I want to get it alone. So everything on the right side has been multiplied by itself. So to get rid of it, you do the opposite operation, which is division. So I'm going to divide both sides by pt, and I find that r is equal to I over pt. Okay. On example 7, I want to get b1 by itself. So this term right there. So first, I want to get rid of that 1/2, and I can do that by multiplying by 2 on both sides. So 2a is equal to h times b1 plus b2. So next, I need to get rid of that h. So 2a over h is equal to b1 plus b2. And again, I want to get b1 by itself, so that last step is going to be to subtract. And so my final answer is that 2a divided by h minus b2 is equal to b1. Right. Last one, I want to get a by itself, and it's stuck inside a radical. So before I can do anything else, I need to square both sides of this equation. So n squared is equal to b squared a minus f. So I'm going to add f to both sides. And then again, I want a by itself, so my last step is to divide by that b squared. So n squared plus f all divided by b squared is my final answer. And that is solving literal equations.